Chima here, and welcome back to the channel. Today we'll be solving Leetcode problem number 200, number of islands. So let's get to it. So for this problem, we're given an m by n 2D binary grid, which represents the maps of ones, which are lands, and zeros, which are water. And the goal here is to return the number of islands, so the number of total islands. And it says here, an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically, and we may assume all four edges of the grids are surrounded by water. So, for example, here in this grid, it says we can assume that all four edges are surrounded by water. So anything that's outside of the grid, over here, example over here, over here, over here, out of bounds over here, out of bounds over here, and out of bounds over here, you can assume those are surrounded by water as well. So this is the very typical depth first search problem, very popular one here on Leetcode, as you can see, has 22,000 likes. So yeah, with this problem, we typically want to do depth first search, and since the goal here is to count the number of islands that we have in our grid, we can begin our depth first search whenever we encounter a piece of land and just traverse our grid in such a way that we explore all other potential pieces of lands, as it says here, horizontally or vertically. So let's go to the drawing board real quick on Paint and let me explain that. So this is the second example here that they gave us in Leetcode, or this is the first example that they gave us here in Leetcode, and for this example, we have a 1 as output, and I'll be explaining why that is. So as I said here, we want to do depth first search whenever we encounter a 1 here, or a piece of land. So the first piece of land that we encounter in our grid, if we were to start traversing it from the top left, will be this one here. So if we were to go vertically, we know we can go vertically up or down. If we were to go horizontally, we can go either left or right. So from this cell, we can go up, we can go left, we can go right, and we can go down. Right, so when we do this, we see that when we go up, this immediately returns as it's out of bounds here. So everything outside here is surrounded by water. And when we go left, we also see this immediately returns because it's also out of bounds. So now when we go down, we hit this other adjacent pieces of land here, and we see that this is a valid piece of land, so we can continue to do our depth first search here. So our depth first search from this node will be up, left, down, and right. And from this node, when we go up, we see that we've already explored this previous node over here. So we don't have to re-explore that node because our goal is to count the total number of islands. So re-exploring a node doesn't help us do that. So we can immediately return here when we go up. When we go left, we're out of bounds here. So we just return back to, here. And when we go down, we see we hit another valid cell here. And we just repeat the same process, right? So up, left, down, right. In this case, going left returns back, going down returns back because the 0 is counted as water. Going right brings us to this one here, and guess what? We repeat the same process. So up, down, right, left. You can see in this case when we go down, we get we hit a body of water. When we go left, we hit a previously visited island, so we return. When we go right, we also hit body of water. So we continue to do this process until we fully explore all connected pieces of lands that are vertical and horizontal. Right, so this is the entire piece of land that we're looking at right now. This is a valid island, and as a result, we can say that we found one piece of land. And when we go to traverse our grid, we notice that there aren't any other possible pieces of lands that we can traverse that aren't already connected to this particular land. So we can just say that our algorithm is done. So that's basically what we're trying to do here. If you're not familiar with the depth first search algorithm, you might want to look up as to how to implement that in code, but I'll be going over it right now as I code. But it might be also important to figure out how the stack works, how we use a visited set to keep track of the nodes that we've visited before. So let's go ahead and do that right now. So we have a visited set to keep track of all the islands we visited, and we want to begin our depth first search. So for now, I'm going to do depth. Since it's helper method, I need to pass that. I do need the particular row and column. And results equals 0 and return results. So we're going to traverse our grid and begin our depth first search whenever we hit the first one. So here I'm going to say rows calls equals grid. So get the length of our grid lengthwise and heightwise. Then we're going to go for I in range rows, for j in range calls. So we begin our depth first search if we haven't previously visited a particular node, and if that particular node is aligned, or if that particular cell is aligned. So that's what I'm going to do here. So if grid at I j equals 1 and grid I j, or rather I j not visited, then we can begin our depth first search. All right, so then we're going to do depth first search row column, and we know that whenever we return back to this calling, whenever we return back to this caller, right, like whenever our depth first search finishes, we can just increment a result value, because that basically means that we've traversed all possible cells that are connected horizontally, vertically to our initial piece of land that we found here. So when we do that, we just so plus equals 1. And actually, it would make more sense to do that before or after. I just prefer to do it this before, because logically to me it makes more sense, but it wouldn't really matter in the code. So now let's go into the main depth first search algorithm here. So we need to think of our base case. So with depth first search, there's 3 main things that you want to do. So base case, process node, and recursive calls. Right. So in our base case, we know that we need to watch out for out of bounds and previously visited lands, right? Because that's basically what this question statement tells us to do. We need to assume that all 4 edges are connected by bodies of water, and also all zeros are water. So this is the 3rd thing we need to watch out for bodies of water. So let's handle all 3 of them with 3 different if statements. You can actually put them all in one if statement, but for the purposes of this video, it will be better if I were to demonstrate it in 3 separate if statements. So if r is less than 0, or r is greater than rows, greater than equal to rows, or say here rows, we just want to return. If c is less than 0, or c is greater than equal to calls, return. Then I'll group these 2 together. So if rc in visited, return. or our grid at RC equals 0, then we return. So to make it a little bit easier to see what I'm doing here, so those first two if statements cover the out of bounds case. The last if statement covers previously visited bodies of lands, and also if we were to hit a body of water while we're traversing our grid. Then to process a node, all we're really doing here is we're just going to mark the specific cell as visited. So what we need to do here is just say let's hit the add ij, or not ij, we said rc. Then we do our recursive calls. Up, down, left, right. So to go up, that means that we're so to go up here, that means that we're going up in our grid, which means that our row value is going to be subtracted from the current value. So what we do here is to do r minus 1, then c dfs. To go down is going to be r plus 1, same column that we're on. To go left, the dfs r remains the same, but we're going left, so that means column gets subtracted, c minus 1, dfs r c plus 1. So with that being said, I believe this should be the entire code. Let's run it and see how it goes. Where it's not associated with a value. Okay, so what I had done incorrectly here was I called or created this helper function below where it's, so if I just do that here, then it should be fine. And since I did that, I'll have to change where my visited is, or there's three variables here. I have to put them up here, just so my helper function has access to these variables and I don't have to pass them into every recursive call. So let's try it again. That's about it for this question. Let's submit it, see how it performs, if it works. And this works perfectly fine. If you have any more doubts about this question, if you need any more clarification, don't be hesitant to leave a comment down below. I'll be quick to respond. And yeah, I hope my explanation was good for you. And don't forget to like the subscribe button and have a good day.